All right, so we just looked at, in section 4, all these special parallelograms, the rhombus, the rectangle, and the square, and these properties that justify them, and these things that are true about them. In section 5, we're going to kind of look at this the opposite way. We're going to say, hey, how can I identify what specific things have to be true in order to know that this is either a rhombus, a rectangle, or a square? So we're going to have a lot of theorems here. I don't want you to get caught up in the wording of the theorems, just know the idea behind them. And so we're just going to start with our first 3 theorems, and we're going to spend the rest of the time identifying what type of figure we're looking at. So we start here with theorem 6-16. It says that if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So all we have to know in order to identify this as a rhombus is if we see perpendicular diagonals and we know it's a parallelogram, then it's definitely a rhombus. That's all this one's telling us. If we look at 6-17, it tells us if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So again, I have to know I have a parallelogram. I have to know I have opposite sides parallel or any of those conditions for parallelograms. But then if I also see, like I see here, BD is a diagonal and it's bisecting the angles, meaning it's taken angle ABC and cut it into 2 congruent angles, 1, 2. We can see they're congruent by their markings. And angle ADC and cut it into 2 congruent angles. We can see angles 3 and 4 are congruent by the double marking. Then I know I've got a rhombus. So if either one of those things are true, perpendicular diagonals, or a diagonal becomes an angle bisector, I know I have a rhombus. We've just got one that we're going to use for rectangles, and that's theorem 6-18. And that tells us that if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if I know my diagonals are congruent, and I know it's a parallelogram, then I know it's a rectangle. And just like with section 4, if I can identify something as both a rectangle and a rhombus, I'm going to go one step further and call that a square. Don't leave it written as both a rectangle and a rhombus. All right, so our next examples, we're just going to look at identifying these. We want to know, can we conclude that the parallelogram is a rhombus, rectangle, or a square? And always explain how you know. So let's look at part A. Again, we're told it's a parallelogram, so we know that properties of parallelograms are true. And they've got this diagonal drawn in, and I'm just going to go ahead and label this A and B. Notice AB is a diagonal, and it cuts angle A into 2 congruent angles, and it cuts angle B into 2 congruent angles. So we've satisfied this property right here, theorem 6-17. So I'm just going to jot down a few notes here. So we're going to say by theorem 6-17, and I'm not really concerned that you have those memorized by any means. I just want you to know where you can find them and that you're looking at them to guide you in identifying these parallelograms. So by theorem 6-17, we have a rhombus. Just like with section 4, don't stop when you figure out one of the properties. See if it has any other properties to take you further. In this case, all I know about this is that that diagonal AB is creating 2 pairs of congruent angles. It becomes an angle bisector. I don't know anything else. I am good to go with stopping there. Let's look at part B. First thing I want to notice here is that I've got these diagonals, and again, I'm going to go ahead and label this E, F, G, H, so we can talk about the diagonals by name. And I do notice that E, and actually I'm going to put J in the middle as my intersection. I notice here that these diagonals intersect at a right angle, right? They're perpendicular. EG intersects HF at point J, which is a 90-degree angle. So let's review that very first theorem we talked about today. If the diagonals of a parallelogram are perpendicular, then we have a rhombus. So we already know EFGH is a rhombus. And I'm going to abbreviate perpendicular by using that kind of upside down capital T. So since the diagonals are perpendicular by theorem 6-16, this is a rhombus. Don't stop there. Do we know anything else about this? Well, notice EJ is congruent to JG, which means that, and HJ is congruent to HF. So since these 4 segments are congruent, the longer segment that makes the diagonal, HF and EG, have to also be congruent. So HF is congruent to EG. They're each 2 tick marks long, meaning the diagonals are congruent. So if we review our properties, this last property we looked at, theorem 6-18, said if the diagonals are congruent, we're looking at a rectangle. So this has to be a rectangle by theorem 6-18. But we've been saying all along, if we identify a figure to be both a rectangle and a rhombus, we don't want to leave it at that. We want to take it one step further, be as specific as we can. If it's a rectangle and a rhombus, then we're looking at a square. Never leave that out. If you're doing multiple choice problems, identify it as a square. When we're asking to identify a parallelogram, we always mean the most specific we can. So even though it is a rhombus, that's not the most specific name for it. Our most specific name would be a square. All right, looking at our next problem, it's asking for what value of x is parallelogram ABCD a rhombus. So we know we have a parallelogram. We want to make it a rhombus. And notice that we have this diagonal BD drawn in our picture. And we have that property in this lesson that said if we have a rhombus, if we have a diagonal that is an angle bisector, then we have a rhombus. So we want to make BD an angle bisector, meaning we want the measure of angle ABD to be congruent to angle DBC. If that were true, then we'd have a rhombus because that diagonal would be an angle bisector. So we want 6x minus 2 to equal 4x plus 8. By using that substitution, we've created an equation, one variable we can solve. Start by getting your x's on the same side, subtract 4x from both sides. 2x minus 2 equals 8. Add 2 to both sides. 2x equals 10. And lastly, divide both sides by 2. X equals 5. Always double check that you're looking for x and not the angle measure. In this case, it is asking for the value of x. So we know if x were to be 5, these 2 angles would be congruent, and I would have a rhombus because my diagonal would be an angle bisector. In our last example, we're going to look at a rectangle here. Similar type of question. For what value of y is parallelogram DEFG a rectangle? So we had that theorem that said if a parallelogram has diagonals that are congruent, then that parallelogram is a rectangle. So, and we looked at this kind of in maybe more detail when we looked up here at this first problem, and notice that it has the tick markings from the end point or the vertex to the point of intersection. And we said, hey, since each of those diagonals have 2 tick marks, they're congruent. The same thing is true here, that e to this point of intersection is going to be the same as this 5y plus 3, and d to the point of intersection is going to be the same as 7y minus 5. If those diagonals are congruent, then we have a rectangle. So we want 5y plus 3 to be the same length as 7y minus 5. Now one equation, one variable, again we can solve. Let's get our y's on the same side by subtracting 5y from both sides. So 3 is equal to 2y minus 5. And now add 5 to both sides. We get 8 is equal to 2y. And lastly, divide both sides by 2, and we get 4 is equal to y. Again, double check that that's what you're asked for. We are looking for the value of y. That would give us a rectangle. If y was 4, we'd have those portions of the diagonals congruent, meaning our diagonals would be congruent. If you have questions on any of these theorems or properties, please let me know. Otherwise, just continue to practice with them.